Right, this is a combination of lessons 3.1 and 3.5. So we're only doing part of 3.1 and then switching to the other section. So first, our objective is to identify parallel, perpendicular, and skew lines. You probably are somewhat familiar with parallel and perpendicular, but maybe not skew. So what does that mean? Right, remember, as you listen, you'll need to pause so that you can get your notes done, and also pause when it comes to examples so that you can work the example and check for your understanding as you go through this. Okay, it says parallel lines, and there's a symbol right there with the two up and down lines. That means it's parallel to. Parallel lines are coplanar and do not intersect. So in the figure, you'll probably need to draw that figure to make your notes make sense. But we've got line AB at the back of that diagram, and then EF forward. Those are both, if you want to think of that as a box, those are both on the top of the box, the front edge and the back edge. There is a symbol here, see this red arrow? That red arrow indicates that those lines are parallel. Even if they're not drawn perfectly parallel, because of the marking, we know they're intended to be parallel. Then the other example they gave us was EG and FH. Those two lines are parallel. See the double arrow markings on those? That's indicating that they pair up to make parallels. So now, because there are no arrows on like AC and BD, it looks like those are parallel, but we can't be sure. So if you're asked to identify parallel lines, you should not be saying AC and BD are parallel. We don't have anything that could support that. They're not marked, and we don't have any theorems at this point that would help us out. So watch for the markings for the parallels. Okay, perpendicular lines. Notice the symbol there, that upside down capital T. That in a sentence would mean it's perpendicular to. Perpendicular lines intersect at 90-degree angles. So in the figure, line AB and line AE. Notice where they come together. Line AB, AE. There is a marking in the corner where they meet. It's a red square corner. I've kind of highlighted with green near it. That marking in the diagram means that that is a right angle. So if you're forming a right angle, then you talk about the lines being actually perpendicular. Notice there's another right angle marking in the diagram. So which two lines come together to make that one? It would be line EG and line GH. So those two lines are perpendicular. They form a right angle. So skew lines. Oh, back to perpendicular. Perpendicular lines are going to be coplanar because anytime lines intersect, they would have to be on the same plane. Maybe it's not the one you've pictured, but there is a plane that would contain both of those lines. Okay, skew lines. Skew lines are not coplanar, so we're not going to get them both flat on the same plane. Skew lines are not parallel, but they also do not intersect. So that means it is that they are going like different directions, but not meeting, not intersecting. They are separated from each other on different planes, going different directions. Let's look at their example. Line AB, which is at the back, and then line EG, which is going up and down. Now think of that in 3 dimensions. EG is on the front face going up and down. AB is on the back of the top face going left and right. They're not going the same direction, and it looks like maybe they would intersect, but think in 3D. One is further back than the other one, so they are not intersecting. That would be an example of skew. So let's talk about a few more examples of skew in there. Okay, line EF is skew with DH. EF, DH. They're not parallel, but they're still not going to intersect because one's higher than the other. They're on completely different planes. Might try a few more examples. BD and AE. BD and CG, BD and GH, BD and EF. There actually are quite a few pairs of skew. Okay, then they also mention parallel planes. Those are simply planes that are parallel. They don't intersect. Parallel planes cannot be coplanar. So parallel planes are not intersecting. So that would be like the top of that example and the bottom of it, plane ABE and plane CDG. Or you could probably do the front and the back as parallel planes, the left and the right. It's kind of hard to put markings on to indicate just the planes, or that the planes are parallel, not the lines are parallel. So we have to, I guess, visualize, and you're probably telling more what appears in the picture to be parallel. They will clarify in some directions where there are some parallel planes also. The symbol for parallel can be used in that sentence also. So an example. Before the example, segments or rays are parallel, perpendicular, or skew if the lines that contain them are parallel, perpendicular, or skew. So it doesn't always have to be a complete line. You can have parts of the line parallel, perpendicular, or skew. Okay, now you're going to need to pause this so that you can identify what it's asking and then start it back up to see if your answers were right. Right, as you start back up, these are the answers that I have. Parallel segments. Notice this picture, it is calling it segments. So BF and EJ have the same marking. You could have used BF and DG or CG. All of those with the one arrow are parallel. Another pairing that you could have is like on the top, segment BE and segment CD, the double arrows, so they are parallel. There are some other segments marked that same way. So you could answer number one multiple ways. Skew segments, a pair that I have would be BF and DE. You could have BF and JH. Make sure the two that you named are not going the same direction, and are not on the same plane, and they don't intersect. Perpendicular segments, there's only one right answer on this whole diagram because there's only one perpendicular marking with segment BF and segment FJ. Then parallel planes, I went with the bottom, plane FJH, and the top, BCD. You just use 3 points when you name the plane. Just make sure those 3 points are not completely collinear. You could have named the front and the back, the left and the right. There are, again, various answers on that one. Okay, here's another diagram. Let's have you do the same thing. Pause so you can answer. Okay, and then going through answers that I had, and just like on the last one, these are not the only answers. For C, there is, if you look at the bottom of the picture, there are 1, 2, 3 different perpendicular markings. So you could have 3 correct answers on part C. Okay, now we're going to jump to the section 3.5. We'll leave the angle part of 3.1 till tomorrow. But we're going to do a little bit of review of lines and then look at the slopes of parallel and perpendicular lines. So from algebra, what is slope? Okay, slope is describing the slant of a line, the steepness of the line. It gives you the rise compared to the run. So we can describe it in different ways. The slope of a line, these would be some notes. The slope of a line in a coordinate plane is a number that describes the steepness, and any 2 points on the line can be used to determine the slope. Why could you use any 2 points on the line? Well, if you picture a line, which in geometry we've emphasized is a straight series of points, it's not going to be steeper in one section than it is in another. So any 2 points give you a section to check the slope. It will never change. Now from slope, you can also tell whether the line is going up as it goes to the right or down to the right. That would indicate a positive slope or a negative slope. So here's your notes on slope. Again, pause so you can get everything written down. So to review, rise is affected by the y coordinates. So if you subtract the y's in the ordered pairs, you would know how much it rises. And run is the horizontal. Again, subtract the x values and you'll get the run. The slope then is making the comparison of rise to run. So fraction, where rise is on the top, run's the bottom. There's a formula there at the bottom of the notes. This is the actual slope formula. As long as your points are labeled correctly, x1, y1, x2, y2. It does not matter which point you call the ones and which you call the twos. You just can't mix it up. If you do that, then you're going to have positives and negatives coming out wrong. So on the example that's here, let's see if we could do the formula to come up with the slope that they have by counting rise and run. We're going to identify the points. This bottom point is 1, 1. That upper point is 5, 7. So if I use the slope formula, y2, 7 minus 1 for the numerator, and on the bottom, 5 minus 1. So that's where you get the 6/4, and that reduces 3/2. We often do leave slope in a fraction because if we are graphing, we're going to want those separate numbers, rise and run anyway. So now time to practice some. I'll pause on each one for you to work it. And use the slope formula, it says. Find the slope of line AB. So find the coordinates and subtract. Now that one has a 0 in the numerator. So that does equal 0. Not that there's, I guess I don't like the word no slope. It does have slope, it's called 0, meaning it's not rising at all. Slope of AC, that ends up being positive, negative, negative 5/6. As I was looking at the line, I thought that's not right, but now I see it. The negative as it goes down to the right. How about line AD? That one goes directly up and down, vertical. So when you subtract there, you do get a 0 in the denominator. Now you can't divide by 0. If you try the long division, it just does not work at all. So that one is called an undefined slope. Not that it has no slope. So undefined is when it is completely vertical. So 0 slope and undefined slope are two different situations. One is horizontal, one is vertical. On the undefined, I like to describe it as this vertical line is so steep you can't even describe it. There's no such number. It's undefined. Hopefully that can help you too. Okay, so on this last one, we still have to do CD. Calculate its slope. And it is 1/6, up 1 and then over 6 to get from one point on the line to another. Now you could have done those last examples by counting, but you really do need to know how to do the formula. You're not going to want to graph everything we do and count. So use the slope formula to calculate. So now I'm not even going to give you a picture. Here are 2 points. Use the slope formula to determine the slope of that line. And the solution, it was simply 2. Okay, you've got a summary now of what the lines look like. If they have a positive slope, they're going to be going up to the right in some steepness. Negative slope, the line will be going down as it goes to the right. Again, it could be various steepness. A zero slope is a horizontal line. If you get confused, write down this line is horizontal. And since there is no rise, the slope is going to be something over, or excuse me, 0 over some number, which is 0. The undefined slope is a vertical line. And when you figure that slope, it's going to be some number over 0. And you can't do that, spelling it wrong. So undefined slope. There is no such number. Okay, so then we're going to do a little bit of experimenting. I think I've set it up here to do on graph paper. We're going to take a look at parallel lines and perpendicular lines. So this will take you a little bit of time to graph these to take a look at. But there are two different ones here. Graph the line through the first 2 points. And then make a parallel through point 0, -1, but it still has to be parallel to the first line that you put up there. Find the slope of each line. Example number 2. Graph the line through C and D, and then graph a parallel to that line that goes through 0, 0. Find the slope of each line in that situation. Now what you should find when you calculate the slopes, the slope of each line is the same. Now think about parallel. If you're going to get those lines to tip the same amount, their slant, their steepness has to be identical. So the slope of parallel lines will always be the same. Now do some creating of perpendicular lines. So grab some graph paper, graph line AB, and then line B, that's the same point B, G. Find the slope of each line. Do the second one, graph C and D, and then connect D to E to make a perpendicular line. Find the slope of each. You should find the slopes of these perpendiculars are not the same, but there is a relationship. You notice that one is positive and the other is negative? And you also notice that you could, in fraction form, flip them over to get the other one? Perpendicular lines have slopes that have the relationship that one is the opposite sign and reciprocal of the other. What do you get if you multiply the two slopes? Notice that it simplifies to be -1. That's the way the theorem will state the relationship for a slope of perpendicular lines. Okay, so what did we just do? The relationship between the slopes of parallel lines, they were the same. Perpendicular lines, they were reciprocals and they have opposite signs. So what's going to happen to two lines that just, they don't have the same slope, they don't have opposite reciprocal slopes, they're not parallel, they're not perpendicular, they will intersect, but not at a specified angle. So these lines would intersect just at a random angle. And you can try that. Draw yourself a line with a slope of 2 and one that has a slope of, I don't know, 1/3. Going from 0, 0 would be easiest. And you'll notice that they both intersect. Okay, so here are the two theorems that have the parallel line slope relationship and the perpendicular line slope relationship. Notice that they also on that theorem 351 also says any two vertical lines are parallel. They put that in there because remember the slope of vertical lines, there's no such number, it's undefined. So you can't say that they have the same slope if there's no such number. You can't describe what the slope is. So the way that they account for that is just clarifying in that theorem. Vertical lines are parallel. The perpendicular line theorem, notice that they didn't use the opposite reciprocal words. What they worded it as if the product of their slopes is -1. So if you multiply the slope of each line together, you will get -1 if those lines are perpendicular. Now that doesn't work on horizontal and vertical, because what would you get when you multiply undefined, which is no such number, times 0? What do you think you would get? You can't even do it because undefined, there's no such number. Anyway, you're not going to get -1. So they do want to clarify, yes, vertical lines and horizontal lines make a right angle. So that's just an extra statement that is included in that theorem. All right, so here's a check for you to do. You need to find the slope of line AB in the first one. You need to find the slope of CD in the first one. And then comparing those slopes, you'll be able to tell if those lines would be parallel, perpendicular, or neither. Now it says graph to verify your results. Let's see if you've come up with the right things just by calculating or if we need to double check. And I'll talk about double checking the parallels after this. So you're going to need to pause so that you can do some work on the slopes. Okay, here's what I came up with. The first one, they both had the same slope. So those lines are parallel. Those slopes are not the same, but they're also not opposite and reciprocals. They wouldn't multiply to be -1. So those two lines are not parallel or perpendicular, so we'd say neither, which is going to mean they will intersect, but not at a specific angle. Number 3, if you don't recognize those as opposite reciprocals, write them both with a denominator of 1 so that you can see a fraction that flips over. If you multiply those together, the product is -1, so those are perpendicular lines. Number 4, same slope, parallel. Those slopes are opposite signs, and you can easily see the reciprocal, so those are perpendicular. Now we really do need to go back to number 1 and 4 a little bit more, because lines that have the same slope might be lined up and really be two copies of the same line instead of two separate lines. If they're the same line, you can't say that they're parallel because they actually are intersecting a lot. So we would need to take number 1 and number 4 and graph those to make sure that they're two separate lines. So that's the part that is kind of tricky with the parallels. So here's what I'm talking about on that. So these two lines appear that they would be parallel because they both had a slope of 1/2. But when you graph all those points, I'll back up so you can get the points again if you didn't get them. Graphing those points, they all are lined up. They're all collinear. So you would really say that they're not parallel, even though their slopes are equal. It's like two copies of the very same line. Okay, so on this I want you to double check and make sure that if you think they're parallel, you graph them and make sure that they are two separate lines and not all in one line. Okay, so figure slopes and then see what you can do for the answer. On this one I have slopes that indicate opposite reciprocals, or slopes that are opposite reciprocals. They multiply to be -1, perpendicular. Next example, find the slopes. The slopes are not the same, but they're also not multiplying to be -1. So here's a neither. They would end up intersecting, but it's not a right angle. That's what the picture would look like. Next one. Slopes are the same. Okay, before you say parallel, graph and make sure that they're two separate lines. And they were. Next one. Oh, this one's a vertical line and a horizontal line. So perpendicular should be your answer. And that's what it would look like. Okay, so check some understanding here. Again, pause so that you can work them, and then I'll show you what the answers are. Are you getting them right? All right, that's the conclusion of the lesson. That was 3.1 and 3.5, parts of those combined.